Okay, so very good evening to everyone, and welcome to the monthly meeting of the Sri Lanka DevOps community. My name is Malin De Silva, and I am a MVP for Microsoft Azure. Some of you might know me. And today we are going to speak a little bit about the serverless side of things, and something that's quite promising and been there for a while is the Azure Functions. Many organizations have transferred their applications to cloud, and they are going through these serverless technologies, and Azure Functions have been very uh, important part in their services that they have been doing. And one of the function templates is the Azure durable functions, and actually it's not a you cannot say it's a stateful function, but it manages states, because when it's serverless it's not easy to manage. So we are going to speak a little bit about that, and we'll be going through a little few demonstrations and see how things are coming together, right? So the first question is, what is serverless? Now, in a normal thing, in a normal thing, you might get it misunderstand that there are no servers. No, there are servers. You can't run anything without servers. But the thing is, these servers are abstracted. So what do you mean by abstracted? So the developer does not need to worry about the servers, updating them, patching them, and whether there are any issues with the server or anything. That's totally taken out of developers' responsibility by the Azure itself. So it's a very easy thing to do, because for the developers now they can only focus on uh, doing what they want to do in their code. There are many APIs. There might be some limitations, but most of the APIs are very much available. So it's very easy to work with and really consider and really concentrate on what you actually need to achieve with that. And then it's instant and event driven. So what do you mean by instant? Yes, so whenever you need a function to trigger, you can instantly trigger it through a HTTP call, or might be a database entry or something like that. And it's based on the event driven. So as soon as it happens, it just works the same way it is needed to. Right. And the third one is the highly scalable, because it is serverless, and it can be scaled up very easily, because when we say serverless, that means all the infrastructure is taken care of by the Azure itself. So whenever you need, you can scale it up, your performances will be higher, and whenever you don't need it, you can scale down and manage it depending on the service that you use. And another important thing is it's pay per use, so you don't need to provision servers and keep them switched on and be charged every time, just like virtual machines or something like that. So there are two different consumption plans on Azure Functions, and if you select the normal basic general thing, then it will trigger up as soon as you hit or trigger the endpoint or something like that, and then it will continue to do the work that it's supposed to do, and then we'll go to a sleep state. So it's only using a very limited amount of resources out of what you need. So it's very much cost effective, because you only pay for the amount that the function is running. Right, so now let's look at what are the type of triggers. Now Azure functions are based on certain triggers, so you can let these triggers be like a blob storage on Azure Storage, or a Cosmos DB, or Event Grid, Event Hubs, and one of the most commonly used is the HTTP and webhooks. It can be a REST endpoint that you hit with it. So whenever the REST endpoint is hit, the event triggers, and whatever the execution needed in the function itself will be executed without issue. And then storage queues, service bus, stable storage, and timers. This is very important, because one of the most important part is having scheduled workloads in your applications. Now having scheduled workloads can be managed with other options, was managed in other options in history, like Windows services, the other web jobs, and so on. But with Azure Functions, you can set it to run on serverless way on Azure itself. So it's very easy to work with. We will see more about them when we go to the demonstration and we do a brief instruction there. And now I said it's serverless, and we have quite a lot of options out here. And what are the difficulties with going with serverless? Now, if you have used Azure Functions, you might have seen some of these difficulties itself as well. And the image source is from docs.microsoft.com video. So if you go there, you can see this in much detail. But in order to just run through these quickly, let me explain a few. So if you look at the first one, just let me highlight this. Yeah. So if you look at this first one, you can see manageable sequencing, error handling, and compensation. So Azure Functions are designed to do a specific task. Now you might be having a process that might contain a set of several tasks. Now for example, if you hit a certain endpoint, you might need to create an invoice, then you might need to send a goods order, or so many things can be done in sequence. So how do we sequence all of these together is a sort of a arguable or troubled area in Azure Functions. Because if you include everything in a single function, depending on your workload, you might get timeouts, you might get other troubles, and because it's not the way how the functions are designed to work. So it's important that you understand the best way to do it, and we are about to speak about it. And then other thing is fanning out and fanning in. So what is fanning out and fanning in? Now imagine you have a single operation here, and then you need three certain branches. Now for example, someone will be triggering a process for a leave approval. Now his immediate boss and some person in another department and some person in another department. So all three might need to be approving in parallel in order for that person to get in. Or just consider about a polling situation. Now you are a member of the board, and once you submit a proposal, every board member shall be approving it. So this process needs to be parallel, right? Because you can't wait for a single board member to approve and the other one to approve likewise. So this needs to fan out, and after everyone or a certain set of people have approved, then you need to go to the next stage. So things like that need to be managed in a certain different way. So that's why we have this fanning out and fanning in options here, right? So this is a little bit difficult in Azure Function because it's stateless. Stateless means we don't know at which stage this is in, whether this person has approved, whether this person has not, or so on. So if you don't use durable functions, your options will be running a timer schedule, and then you have to see how many people have approved and then go on. But why do we need that? Because we have Azure durable functions, so we can just utilize itself, right? And then we might have some other external events that are coming into this function's execution. For example, there can be webhooks, there can be some manual triggers or some things like that. When those are triggered, we might need a particular Azure function to trigger. So the external events handling is not possible, specifically in this case, because you can see three inputs are coming to a single function. That's not easy. And then we need long running processes. So doesn't matter what you have in your flow, what you have in your idea. So you might need it to continue and loop through itself. So how do you do it in Azure Function? Because Azure Functions are serverless, and what you mean by serverless is they wake up, they execute a piece of code, and they go around. So this needs to be handled in a particular way in order to do it in the serverless architecture. So that's where durable functions will be helpful. We'll be speaking about it a little bit. And then HTTP based and asynchronous long running APIs. Now you might have different APIs that might trigger something here and get a result back. Now for example, if you are connecting to a payment gateway, right? So once you receive a request from the payment gateway, you might need to send a response back, right? Because you might have processed some sort of warning. Now if you use a function, if some sort of an exception happens, there is no way to guarantee that we send our response back. So with durable function, send back that response. So it's guaranteed that a response will go on after interaction. So how do we handle human interaction? Now think about the approval flow there, just like I explained earlier. Now an Azure function has certain triggers that need to trigger up. So you might get a little bit disorganized if you have your function, if you have your flow divided into like 10 different uh, functions like this. So the goal should be to have a single function that starts from the beginning and do whatever the things that you need to do. You can wait for a certain time, you can get a human approval on a certain thing, and then finish up once the task is done. So this is also not possible within a normal trigger based function. And then comes the durable functions. So what do? They are long running orchestrations as a single function. Now you might get misunderstood with what is specified here. So they are long running, yes. Actually they are not long running functions themselves. They are long running function orchestrations, right? So what do you mean by orchestrations? So it doesn't mean that your function is keeping itself and running it continuously. So that doesn't happen that way. So there's a particular component that controls the state. So once the state is controlled in a different place, the function will be just waking up and just complete when needed. So things like that do happen with durable functions. And the durable functions are code only. If you look at certain traditional workflows or some other tools, custom based workflows like Mintex or something like that, you might see a flow of things available. And if you even look at logic apps, that's available there. But this is code only. So the developers have much more flexibility to customize it as you need, because when in a design environment the developers might feel a bit of issues with customizing. So what you can do in a situation like this is that you can easily customize it as you need. So it's very much easy to use. And then it supports multiple languages, JavaScript, I think Node.js also there, and C#.NET, which we are going to use, are all supported. So it's very easy for any developer from different technological backgrounds to just come in and work on it. Right, so this is actually a screenshot of a session that's done by Jeff Holland from Microsoft, so credits to him. So let's just see how this total function orchestration is happening. Because as I already said, functions are serverless. Durable function orchestration is there, but the functions that are running inside are serverless. So what are the components of a durable function? First of all, you need orchestrator function, right? So the orchestrator is the thing that is managing all these things. So even it is a function, it will wake up and then shut down once the piece of thing is done. And a single orchestrator function will be calling so multiple activity functions. So within a single orchestrator, there can be multiple activity functions, and then the execution history is stored in the storage account as a blob or as a table storage. So what happens is orchestrator, now if you look at this piece of code, you can see it's creating a list of strings as outputs and adding a set of text as the this list collection. So how does this happen? That's really important to understand, because it's not this normal traditional way. So the orchestrator cannot actually store a state itself inside. So it will be referencing this execution history in needed. Now, now the first step will be the orchestrator starts, right? So the orchestrator starts and it executes, right? It will first go to the context.call activity and we'll send this .NET conf line so to this say hello function. Now say hello is an activity function, right? So the execution starts and the task is scheduled to say hello. So a scheduling is happen to call that say hello function with the input called .NET conf, right? So it doesn't mean this orchestrator will wait, orchestrator will complete, right? So the orchestrator starts and the execution starts and then sets a schedule for this activity function, and then orchestrator then just go to sleep state, right? So what activity function does is activity function will do whatever the operation that's defined inside and then return a certain message or a status back to this execution history, right? So once the task is completed, the activity function is completed, it will return hello.NET conf. So once this is returned, then again the orchestrator starts. So the orchestrator starts and then it will look whether this activity function is already called. Where do they look it? It's in the execution history. So the orchestrator will start again from here and will come here, and in the history it will see whether this call is already made. If the call is already made, it will just return to the next stage. If the call is not already made, then it will just again make that call. So then orchestrator will go to this outputs object and will return the outputs and will complete. Now it's really important to understand this, because you might get a sort of a misunderstanding saying this orchestrator is a function that keeps the state. It will stay until this activity function is executing and doing whatever needs to be done there. Now that's not the case. So the orchestrator starts, assign a task to the activity function, and it goes to sleep. So in the meantime, this happens instantly most of the time. So activity function starts, it does what it's supposed to do, and it will complete. So once this is complete, it gets status updated here, and then again the orchestrator function start and will go from the beginning. It's not starting from where it was. It will go from the beginning and check whether this activity function is already called, and if it is called, then it will go to the next line, which is returning outputs. So once that is done, the orchestrator completes itself. So this is how a function orchestration is happening. So if there are any confusions, better to get clarified right now. So I hope it's clarified the way I explained. We will see it how it happens again when we are doing the demonstration in the next slide. Right. So with that said, let's go to the demonstration. Now I have my Visual Studio 2019 here. What I am going to do is I am going to create a new project, and it's based on Azure Functions. Just we'll go next and we'll say functions demo 2. Right. So assume this is visible. Yes, it seems. And then I will just create this. Now when I come here, it's asking the version whether we are using v1, v2 or v3. I will use the latest, and we'll start with the empty template because it's cleaner, it's not creating anything. And up in here you can see there's a warning that some capabilities may require an Azure Storage account. So what does it mean? There are some capabilities that does not need it, But in our case, as you can see, as you saw earlier, there's a state being managed, so we need the storage. Now I'm choosing the storage emulator, so that means a local storage will be used. But if not, if you would like to use the cloud-based Azure storage, then you can use that as well. Right, so just specify that, and we'll just hit the create button. Yeah, so now I have my functions project created. It's just empty. It has this local settings, host JSON, and all this configuration information there. So what I'm going to do is I will just go here and a new add Azure function and name it like durable demo function. So I'm just adding it, and in the template I'm specifying it as durable functions orchestration. So as you can see here, we have the HTTP triggers. You might already know this, but if you don't know, it's just a quick catch up. So the HTTP trigger is there, and the timer trigger is there. You can see it's specifying a schedule here into the Linux syntax, and the queue trigger. So a connection to a Azure Storage queue and the queue name here, and same with the blob storage and event create and Cosmos DB. So if you want some sort of action to happen when a DB file or a record is created in a Cosmos DB, you can just specify the connection string and the DB name and the collection name. So it's very easy to use with this. Now I just select the durable functions orchestration here, and we'll click OK. Right, so this has created something over here. Let's go through and see what they are. Now if we just go through the code, you can see basically there are three functions, right? So function 1 is the durable demo function. It has a method called run orchestrator, and it's getting me a parameter called idurable orchestration context. This is very important in future. I will show you why. And then we have this say hello function here. So it's an activity function, right? So what does activity function do? I earlier mentioned there can be different activities defined. So there can be multiple activities like this in a normal durable function. And then we have trigger function, right? So how does it triggers? Whenever request is coming, HTTP request comes here, it will be triggered, and it will continue doing whatever the orchestrator does, right? So in the HTTP trigger, as you can see, what it does is it's having the start object in the durable orchestrator client and creates a new instance of this durable demo function, right? So the durable demo function is here, and as you can see, it's creating an instance of it, and then it creates a check status response, so it triggers there. And in the durable function orchestrator, if I come here, you can see there's outputs collection here, a list of outputs of list of strings are here, and then what it does is for three instances, it's calling this durable demo function underscore hello. That's the activity function with a parameter, right? So you can see it's accepting a parameter called string name, and it's calling this. And what happens is in here it's logging the info, logging it as say hello to the name whatever we send, and then returning a hello space name that's there. So it's a pretty simple one, but in reality you can have calling a database here. You can do a sort of, you can maybe making another REST call and get outputs and do certain calculation. Anything complex you can write within these activity functions, so there's no issues with that. Right, so let's just start this and see how does it work. Now if I just run this project, the console window will pop up. Right, so as you can see, the function core tools are running and the runtime version is what I selected, and as you can see there are three functions out here. So the durable demo function underscore http task http start, that has this URL here, and then durable demo function, it's the orchestration trigger, as you can see here, it says that, and then durable demo function underscore hello, that's the activity trigger. Now as I earlier said, we need to send a get or post request to the durable demo function http start in order to get this function going. Right, so let's put a breakpoint here as well, just so I can show you it. Right, and I will come here and just hit it, so it basically sends a get request, and I will continue this. What happens is it comes to the orchestrator function, and as you can see the first function call is available here. Now I am running this, right, and what happens is it's coming back again, but if you look at the output, okay, yeah, seeing hello to Tokyo is here. If I just execute this line, it goes to the next one and it comes back here. Now I earlier said it's maintaining the state, so it doesn't call this Tokyo, this say hello to Tokyo thing repetitively. So that's what important to see. So if you come here, we have say hello to Tokyo and say hello to Seattle. And if you have noticed earlier, it didn't come to this line on that line's execution. Right? So it just came up here. And if I just run it again, it comes here again. As you can see, it's not returning the outputs yet because we are waiting for this this function to return a value. Right? Now what has happened is it's saying hello to Tokyo, saying hello to London, and saying hello to Seattle, and saying hello to London. Right? If we just execute this one by one, we are not seeing any outputs here again. See, in theory, it shall. I mean, in a normal program execution, it shall be calling here, but it doesn't happen here because of this durable function orchestration, right? And now it's returning these outputs. As you can see, the function has completed. Now another thing important here is that we let me just debug this again and show you that. So let me run it again. So when you are running a durable function, what happens is you can actually get a particular instance ID and check the status of it. See, if you go here, you can see the status query. It's the actually earlier instance there. Right. So I need to trigger this function again. Let me just actually close this and start again. So it feels empty. Right. So it's hitting this breakpoint, and I will continue. Now it comes here. Right. So it comes to here, but if you just check here, the status query get URI. See, it's still at the running stage because it was running by the time I hit the breakpoint, and if I just run it again, it shows as completed. So likewise, we have certain endpoints URIs. So we can, for example, imagine we are running a long orchestrator function for like 10 days. Now this might be this URLs can be stored somewhere else, but what's important is this ID, this instance ID. So you can actually generate this this by that particular ID, because this is authorization code and the connection is storage, task hub is here, and the instance ID is here. So what you can do is you can keep testing the status in somewhere else with this URI, because it's very easy. You can see it's just a matter of call and it gets updated. And then the send event post release here, and the terminate post URI is here, because if it's running for a long time, then you can just click here, just call this REST endpoint, and then you can stop the running function itself. So it's easy as that. And then on the other hand, we have the purge history delete URI. So what it happens is, if you click here, it shall purge the history, right? So yep. So what needs to happen here is, if you just come here, right, you can see all the inputs are there. Now how does this, now earlier in the slide I showed you that the execution history is maintained somewhere, right? Now it's maintained here. So where is this execution history is there? So if I go to my storage explorer, I have this, now if you just go here, you can see in the task hub, you can see test hub name is here. So if I just come to test hub name history, just refresh this. So these are the instances. Now the instance that we ran last time, the one that we ran last time should be here. It's 7780 thing. Now it's here. See, you can see what's the output and everything actually here. See, it says partition key is here, and the execution ID, and the function name, and the output. What are the output, and the runtime status, and the task hub name. All are there here, right? And then we have this test hub name history. It says no data available. Let me refresh. Yes, there are. Now I showed earlier that this orchestrator started, execution started, task scheduled, say hello. So all this information are just available here. Now let me just delete all these. Let me just delete all this, and yeah, let me delete all this, and we'll delete these instances as well. Now in practice we don't do this because it's in the simulator I'm doing here. Right, let me just get rid of these breakpoints and run this for run again. So when I hit this, let me run it again. Let me just debug this again. Just want to make sure nothing is here. Let's refresh or test something. And if I just come here and refresh it, I will delete this as well. Yeah, so I just ran a new instance, and let me go here and hit the HTTP endpoint, and status query, you can see it's already completed. Now it's all good. That means if we just look at for a single instance, what we have here is in the name instance history, we have this execution details. It has sent this output and it has completed. Right, so all that information is here, and in the name history, in the history table, just now you can see the orchestrator started, task scheduled, orchestrator completed. So exactly what's here: orchestrator started, task scheduled, and orchestrator completed. and then again orchestrator start, task completed, and everything is here. And then we can see it like happening for 3 times, and you can see it's calling this function. Yeah, and then the outputs in the results, you can see when calling the 3 activity functions, it's returning hello Tokyo, hello Seattle, and hello London likewise. And then in the output, in the overall output, it's showing here. Now if this record was not here by the time it's calling the hello Tokyo in the second round, then this will be called again. So if you just want to be a little bit crazy, just try deleting this record and try it out. It shall work that way. Okay, so that's basically what a durable function is. Uh, the 3 components are here is the orchestrator function, and then the activity triggers. The orchestrator function will be calling multiple activities. Now the good thing is we can have try catches, and for example if an exception happens, then we can call another function and say clean up all the mess that this has done so far. And if you need some sort of output based on this, you can simply see it's returning a string. You can simply get a string output, and based on that output you can do some actions likewise. So the whole workflow can be defined here without an issue, right? And even if it fails, if you trigger by the same instance ID, it will continue from where it just failed. That's how it is, right? So let's move on to the slides for another one last slide. Yes, so the orchestrator constraints. Once again, this slide is from Jeff Holland. A good big thank you. This is from his .NET conference session in 2018. It explains things quite very well, so I just thought of having it as it is, and credits to him. So orchestrator code must be deterministic. You must know how what exactly is doing, and you shall never use random numbers, datetime, UTC now, GUI.new GID, things like that. So if you want to use the current time, the best way is to use this durable orchestration context.current UTC datetime. Right? That's there, because as we saw earlier, it's going to keep looping. So the datetime.utc now that you get at the first instance won't be the same you get at the second function is called. So need to be very careful with that. We'll see it in the in a little bit later. And the next thing is never do IO directly in the orchestrator. Now the orchestrator function is there for orchestrating. It's not to do any database calls. It's not to do any maybe waiting for the user inputs or some things like that. So the whole idea of having an orchestrator function is calling the activity functions depending on a certain logic, right? So you don't need to be calling the databases, you don't need to be calling the REST APIs and anything, because that has to be happen within the activity function, right? And then the other thing is, do not write infinite loops. So for example, if you want to do the same thing again and again, and you should not just do a for loop. For example, if you want to call Seattle again and again, then you shouldn't write a for loop and do it like that. So the best way is you can do the durable orchestration context and continue as new. So that will do it from the beginning. So it's very easy. Now let's look at this datetime thing, because it's, I think, something that's you need to see it out. So I will just specify a var current date equals datetime dot, that's the system, this UTC now, right? And then I will say current date underscore orchestrator as context dot, sorry, context dot current UTC datetime, right? Now what I can do is I can log this. It shall work. Oh no, the log object is not injected in here. That's fine. We will just do put a breakpoint and see. So I just running this again. Yeah, so the same thing, it started, and now what I will do is I will just create a new instance of this by calling this endpoint. Right, so the current date 2:40 p.m. 11 seconds. It's same here. And I will continue. It comes back, and current date is 2:40 24 seconds. But if you look at the orchestrator in the context, it's the same as it started. So this is why it happened, because you every time this runs, it will keep looping. So now let me just add this to watch, so we can see it easily. Just add to watch, right? So if I run again, you can see the current date is 2:40:56, and this is 2:40:11. So that's why it's saying you just shall use that rather than just looping. And a little bit on the other note, the last one, the use durable orchestration context, because if you do infinite loops, it will create more and more storage history records. So that's not very friendly or very recommended when it comes to doing these orchestrations, right? Okay, so that's it from me. If you have any questions, just feel free to comment on the YouTube video, or just send a message to us on the event page or the Facebook page.